Okay. And the good news is, you go to any soil water district, I am very confident that those guys would help you out if you have questions on controlled drainage, especially. Ohio is one of the leading states where we have implemented a lot of controlled drainage, but the technical expertise on controlled drainage is very high in Ohio compared to any other states in terms of like your soil water districts or even county extension having some of that knowledge.
What's caused us to be ahead? The state of Iowa, the university, you? I mean, what's caused us to be ahead or just?
It's a partnership. The reason why we think that controlled drainage has kind of picked up it as much as it has here. Part one, my predecessors were some of the first people to actually try out controlled drainage and see the benefit to crop yield and things like that. So the research on this started when I was 5 years old. I'm just presenting the work that these guys have done over 20 years. Dr. Norm Fauci, Larry Brown, Barry Allred. There were a lot of people. In fact, the first trial on sub-irrigation was in Worcester. Soybean specialist at that time and Norm Fauci put out a trial. They're like, well, it's a control structure. Can we pump water back in? And they put a trial out there, and they saw some benefit to soybeans back in 1980s. So that was like the early days. But when they saw the water quality benefits, all credit goes to our county level offices, but the state level Department of Ag, Ohio Department of Ag, and NRCS at that time, they all worked together to actually bring in state and federal dollars to incentivize the practice. A lot of the implementation happened because they wanted to solve the hypoxia issue down in Gulf or the Lake Erie issue, and that's why the control drainage was incentivized. And that incentive still exists through H2 Ohio as well as NRCS. You can sign up for this through Equip. You pretty much cover the whole cost of the structure and labor and design if you process the right paperwork through Equip. H2 Ohio is a flat fee. You just get a flat amount paid. But there is a way that you could sign up for these and get that. And I think our county-based soil water districts did an outstanding job of just promoting the practice and getting the signups done. That's part of the reason. But now, in the last 10 years, what I have seen is you rent a new ground, the first thing you do is, it used to be, the first thing you do is look at a systematic pattern. If it doesn't exist, invest into a systematic pattern. They're making an adjustment now. It's systematic tile drainage and a control structure out there because we have shown, I have a slide somewhere that shows uh, 15, 20 years of research shows that 6% yield on average, yield increase for corn if you just simply use control drainage. Just put the bores down at the end of June or early July, about 18 inches below surface. And then basically you remember that bank that I was talking, you bring that up by about 18 inches, 12 or 18 inches, and that is about 2 inches of water out of the 4.5 that you need. As simple as that. So now the guys are seeing that benefit and voluntarily installing structures without even sometimes going the route of Equip or NRCS or H2 Ohio because they know that the 6% yield increase is significant yield increase to them. On average, in a year like 2012, that would be more like 15% because everybody else is not getting that much yield. So that's kind of the reason behind it. Is in the recent years they're, I think, actually investing into it because they see the water conservation benefit. Uh, Something that you might come across is like, one structure at the outlet may or may not help. You may have to have like a series of structures, and there are two ways to achieve that. You could use a structure or you could use an underground, what they call a inline water gate. So basically it's a float based valve system. So technically in this slide, this did not have to be a structure sticking out the ground. You could put an inline water gate and still achieve about a foot of elevation gain on the water table that you're storing behind it. Does that make sense?
Now, where are you talking at? Where you? If you point on the screen, I can't see where you're.
Oh, it's not showing up.
Yeah,
Okay,
it's got the
sorry,
cursor.
my bad.
There
So
you go.
this second structure, you must have a structure at the outlet to basically
Right.
raise the outlet elevation to whatever depth you're wanting it. But if this ground is sloping, then you basically lose the benefit of that raised water level by the time you go up ground,
Right.
up in the elevation. And that's where you need to put another structure that would stack up more water behind it to benefit this part of the field. So now what you could do is, instead of this structure sticking out, you could put a water gate here. Now the difference between a structure and a water gate is that the structure, you can stack up the boards to have like 2 feet of elevation rise. The water gate gives you only 1 foot. So you will need 2 of the water gates, but the advantage is they're not sticking out above the ground. And you'll see why I'm showing
Yeah.
you that, because it's not always um, um, on the design. It's not always like you're not always dealing with a field where the structure has to sit out at the edge of the field. Sometimes your main or sub main runs in the middle of the field, and how do you manage that, so what sites work, I think you already know the basics of it, but let's go through the list. You must have drainage that exists, systematic drainage that exists in a field for your water table to actually rise up or go up and down. So if you don't have any laterals in a field, you're not going to benefit from controlled drainage. That's the first thing. But it's best to have a pattern drainage system. Um, Something to keep in mind is, do you have leakages? Old clay system that is hooked up to a different outlet or just sitting there. Imagine you raise the outlet and you have a leakage. It's not gonna store the water in the profile. The whole idea is to store the water in the soil profile, but it's gonna find its way out. You have a big ditch right next to the field. Deep seepage, lateral seepage is going to take some of that water away from you. Okay, so you don't want to have a perforated main running parallel to a big ditch and then do controlled drainage on it, because then you would lose a lot more water to that drainage ditch through seepage, as long as the water in that ditch is lower than your field elevations, if that makes sense. So there are certain considerations that you have to think about. uh, it's about management, so we have to think about the management aspect. If you could put a structure here right by the road, that's easy to manage, hop off the truck, that's the right location to do it. And then you have to think about where that location could be. um, Main thing is, it does not have to come in the way, like when you're turning your combine or
Right.
whatever, you're likely to hit that and
Now,
so
there where
on.
it says to affect neighboring fields. So
Yeah,
the na-
I'm
the,
listening.
na- the neighboring field, I guess we got a main coming through from the neighbor field. So we would just leave theirs there and just go on each side of that would be the
Yes,
ideal.
that is a very good question. Do you put control structure on a shared main? My advice to you is to never put a control structure on a shared main, no matter how close a friend you got
Yeah.
there. Okay.
Yeah.
um, we always recommend that if you have your own tile main that's coming in, or if it's not coming in, it's very easy to put a sub main in and then put your own control structure on there. Water is a very contentious issue, and tiling, getting rid of water, is even more. So it's better not to plug up the entire flow for you and your neighbors, no matter how high they are in the watershed. It just keeps your system safe.
Now, with so there, the neighbor's coming straight through mine,
Yeah.
and then I put one on each side. Well, theirs really needs to be solid or non-perfed, or with me backing it up, I'm just gonna go, my water is gonna have a tendency to go to there.
So that is a modification you will have to do if you have a shared perforated main, and then there is a control structure right next to it. You will have to change all of that into a non-perf for that particular
Right,
section.
right.
Yes.
And then that would,
Yeah.
because it would defeat the purpose.
It will. Correct.
Especially in the main, because that's where you're backing most of the water up to
Yeah.
get to the laterals.
Yeah, that is a very good point. And then you don't want to have your main to be perforated for a certain length. Again,
From the controlled structure?
From the control structure up. You also want to use a non-perforated pipe, because that main, sometimes you have a situation where you are relying on that main to be your drain pipe for that
Right.
buffer.
But
It may
it's
be
more
easy.
pipeline,
Yeah,
right?
it may be easy to put another lateral, maybe split the spacing there, put another perforated pipe, but then your main to be non-perf. If you have another main right next to it that is perforated. Okay. Um, think about this: a pancake field, perfect for controlled drainage.
Yeah, we
Okay.
have a lot of those.
Yeah, but a stacked pancake field, problem. Okay. The difference is, if you look at that previous slide, there was everything was blue. In this slide, you got these three pancakes. Now you got a slope. All the water is wanting to go down to the bottom of the valley and just pool up there, right? Well, maybe I'll get, I don't know, 10 or 15 bushel more corn in that zone, but is it worth it? That's when you got to think about whether or not stacking of these control structure makes sense. Okay, and I'll come to the slope numbers here shortly, but anywhere between 0 and 1% slope, I don't worry about for the land. But you could potentially uh, extend that benefit further uphill if you could put additional control structures that are individually managing these zones. Okay, and again, I would not want to see a structure sticking out the ground in the middle of the field. You could achieve it using a water gate. I'll show you that here.
But
I
in
think
that pancake side, you could use the below ground.
you could use the below ground. I think it may be here somewhere in the illustration. Look at that.
There.
There you go. So the difference is, as I said, it's just basically an oversized pipe that allows you a foot of head. So um, you would have needed only one control structure. You would have needed one control structure here that would give you 2 feet. Instead, you need two of these, and they're much cheaper, but most importantly, they are not a hassle sticking out the ground. Cost wise, it's all the same, and if you're going the NRCS route, it's all paid for, and they do work. Like a lot of people think that, oh, it's underground, what if it's clogged or whatever. I don't think we have that much of an issue that we have seen with these, so I think it's not it's pretty reliable is what we have seen. As I said, 0.5% slope, less than 1% slope for a field, you can easily put a control structure out there and see the benefit. The only caveat would be if you have sand veins or some kind of a leakage, you gotta address that. You have a random clay tile that you it's good for me because that part of the field I always liked for it to drain using that clay tile in the different direction. Not anymore. You might want to address that through a systematic pattern, or hooking it up with your existing system and disconnecting it completely, destroying it completely. Otherwise, it's gonna leak water. Um, and it's a lot of the landscape here is suitable. There is a suitability tool on that website, on that handout, that you can easily see. But honestly, like, the best way would be to do your assessment, get a soil water district person to comment on it, and then invest into controlled drainage. Don't just invest into it like randomly. Sometimes you may get into situations up in Fulton County. We see this a lot, that they have sand veins and they still get paid for a control structure, but it's no use. I mean, okay, I shouldn't say that.
They're not
It's
getting much benefit.
They are helping the environment. Okay, no doubt about that. As soon as you close that gate and stack up the boards and let the water stay in the soil profile, even if it hits a sand vein, it does wonders for removing nitrogen and phosphorus. On your profitability side, it does not necessarily provide you that yield benefit. So that should be the correct way of saying this, is you don't want to invest into this just because you want to make money. If you're a more conservation oriented guy, you could think about it from that perspective, that the benefit, if you're getting paid for that structure, you're getting paid for that structure to work for water quality, and it's an honor system. NRCS is not policing you. The payment is not tied up with verification that you are actually managing it. It's an expectation. H2 Ohio requires you to manage it for the 3 years after getting paid. I haven't seen them policing it. Okay, so it's one of those things in where, like, it's very American thing, in my opinion, is it's an honor system. I'm done harvesting. I have no use for that tile system because I need active drainage if I'm growing crops. I don't need drainage if I'm not growing crops. Shut that valve off by putting the boards in during the non-growing season. It's helping the environment. If you can keep that in mind.
Now, in the non-growing season, you're still just leaving the boards up part way. You're not closing.
No. Yeah, the only difference is more aggressive. So
You'd go higher in
yeah,
non-growing.
and the operation and management is part of this, but I'll just explain to you, and then we don't have to worry about the slides. Is After harvest, you go back in, stack the boards up so that the water table, when it starts rising, it can come about a foot within the top of the surface in the field. Okay? 12 inches below surface is what NRCS practice standard recommends in non-growing season. Okay, because you could bring the water all the way up to the surface, but then next time you have rain, you're going to see erosion. So that's why we leave about a foot of a freeboard in the field so that rain or precipitation or snow melt can soak up, find its way, infiltrate, and then bypass through the tile system. But 12 inches is ideal in non-growing season because uh, that's when you have the maximum water quality benefit. Oh, I'm a cover crop guy. I don't want wet feet for my cover crop as it's growing. The practice standard then modifies the suggestion. It says, as the cover crop starts growing, start lowering your water table. I made it simple. For Ohio, don't put it at 12 inches if you have cover crop. Set it at 18 inches. Your earthworm will be fine. Your cover crop will be fine, because we think about it as a bathtub. Soil is not a bathtub. Once you raise the water level, it has leakages. So in springtime or winter time, whenever you have the rain event, it will flood the field. Water table will come up, but it will recede down to 18 inches, and it will continue to go below 18 inches even during winter time. It's just very slow. 18 inches, 24 inches, depending upon what your cover crop looks like. Especially in March, if you have rye or whatever, they do a good job. Even if you had 18 inches of profile for those roots, they will start pumping that water out. I'm not worried about it. So you kind of make that decision on the board, 12 inches or 18 inches below surface after harvest. Don't even worry about it until April. I have seen new guys getting anxious about it as you get closer to the planting date. The standard recommendation is 2 weeks before your intended planting date, you should go and open the boards up as if it's free draining completely, and leave it that way until June, until after planting, and even in the month of June. For Ohio, we have too much rain and too much wet conditions in June. We don't want any of that water to be stored. We want our drainage system to be functioning. The more important benefit you have is, imagine how many roots and how much sediment you're collecting in the entire tile system. You want that to flush. So every rain event you got, you're flushing that system out for about 2 months, and that gets rid of all your sediment, all your died roots and everything. It's all flushing out, and then you have a much better system. So my recommendation is, let's say your planting date is May whatever 10th. I would come maybe end of April, pull those boards up completely, let the system flush out. Okay. After planting, typically you have side dress or other operations. Um, End of June is kind of end of your field operations. After that, you're less likely to go out in the field. I'd go out there end of June, depending upon what the season looks like, or early July. And then you remember in winter time, I said 12 inches below surface. You don't want to do that in July. You want to do 18 or 24 inches. I would start with 24 inches as a new guy that is not comfortable with this thing. Essentially what you're doing is 24 inches from surface is 1 foot above the original tile system. So you're making your tile system, instead of 36 inches, you're making it 24 inches deep. It's a shallow drainage system is what you're creating. Let's try that shallow drainage system for one crop rotation, see how it works. Then you can get more aggressive and start storing more and more. I have guys that go out there 2 weeks after planting, put their boards down 18 inches below surface. So midway between surface and tile drain. Forget about it until they harvest. They never go out, except for like a year like 2019, or a season like the 2025 July. If it rained 8 inches in the month of July, yeah, I would go and play with my structure a little bit, because I don't want too much wet condition around that time. So if it's late July, am I worried about it? I mean, corn has gone like early growth stages is when you have wet stress as a factor. If it's late July, I'm not worried about it.
But by raising the boards, we're not really slowing up the drainage
No,
speed. The speed of, or the drainage coefficient remains the same.
everything
We're
remains
just
the same.
just raising it up in
Yes,
the.
yeah. Your water table recession is what you are playing with. In a free draining system, the water table right after a saturation event, let's say rained enough, 2 inches, the whole soil is flooded, and you design your drainage systems to have a drainage coefficient that will bring that water table down by 1 foot within first 24 hours, by another close to a foot in the next 48 hours. That's how our drainage systems are designed. So typically, if it doesn't rain, in a matter of 4 days, you would see majority of field has water table that has receded a couple feet. Your tile systems keep running for about 5 to 8 days in some cases, because you have a large area that is continuing to bring some water in. But typically the water table has receded very fast down to the tile depth within the 4 or 5 days. With controlled drainage, you're bringing the tile depth up. So what is it's going to do is it's going to start there, but instead of going down to 36 inches in the first 48 hours, it's going to stop at 18 inches or 12 inches or wherever you set it up to be. Does that make sense? Okay. Design. We're going to go through this at drainage school more formally, but the middle image is that water gate. It has float system that closes the upstream portion of the tile, and it uses the back pressure from your main control structure to close that. Uh, Now there is an automated control structure that has come on the market. Uh, Typical manual structure that you have seen cost maybe somewhere between $2,000 and $4,000. You add another $10,000 if you wanted access to like a valve at the bottom that you can schedule to be opening and closing or reacting to the water level changes. And I have 15 of these that we're looking at as part of our research. I like it, especially for guys that actually have like more than 30, 40 outlets that you have to manage. And who has time in April to go to 45 outlets and raise these boards? And it's not easy. Like, Tim, have you ever used these? Like the slide gates? Those slide gates that you have when you're trying to pull them up and down. Imagine all the soil pressure is pushing on them. These things uh, distort a little once in a while, and it just gets very difficult to manage them because the slide gates don't help. So in that situation, this automated control structure is a good idea. And the good news is the NRCS payment actually will cover additional cost for automation. So if you're going the NRCS route, go the full route and get the automated one. If you're doing the labor on your own, that's the best way to do it, because then you can charge your full labor on that payment program as well. Um, this is a typical section. This is where I was gonna talk about the non-perf. Um, the standard says that you should have a non-perforated pipe section on either side of that structure for about 20 feet. What that does, it actually keeps your your actual outlet pipe safe. Otherwise, imagine you have a bunch of water on this side of that pipe. It's gonna find its way closer to the pipe. It's smooth. It's gonna start piping. It's gonna start scouring and find its way towards the seepage lines through towards the ditch. So it will start carving out another pipe around your pipe, and eventually you will see a failure. You, that's why you don't want any seepage directly going along the pipe, around the structure, and along the outlet pipe. And that the way to prevent that is, number one, have a non-perforated pipe. Number two, have a anti-seep collar. If the you see a risk of high seepage. In Ohio, we have a lot of heavy clay soils, very tight clay. We usually still recommend anti-seep collars, but there are ways to basically prevent that seepage. It doesn't have to be anti-seep collar. I'll show you that. Do you know what an anti-seep collar is? Have you
No.
ever used these? It has it's almost like a rubber membrane. So you make a little sleeve, slice it in the middle, push your pipe through it. The opening has to be smaller than the pipe diameter, because the pipe has to basically kind of pass through it. And then it's really flexible rubber membrane that you're keeping there for about maybe a 3 feet by 3 feet frame. And what that does, it's snug with the pipe, and any water that is wanting to go along the outside of the wall of the pipe, it's going to stop it and make that water to go around it. As soon as it's going around it, we're not worried about it. Then we're good, because it's preventing the erosion around that pipe. Okay. Now you could do the same thing by putting some bentonite around it. So I have actually liked the idea of using bentonite around the pipe, put a few bags of bentonite around it, and that does the same thing, actually much better than the anti-seep collar. A lot of guys do not install these properly. You, you talk to an engineer from ODA, and they will always find a mistake that you made on anti-seep collars. You throw a bag of bentonite, they'll be okay with it. Of course, sometimes I don't think you guys have that many pumped outlets here. There is some.
There's a few around.
There's a few around.
But imagine, like, if you don't pump, it's controlled drainage.
Yeah, it's already done. That's simple.
But that sump house could be your sub irrigation as well. So uh, honestly, it's very easy to think about it. It's very easy to design it. My suggestion is to get someone else to design it for you initially, see how they are designing it, and then think about how many fields can be suitable. A lot of guys, they don't even worry about designing it. They just throw a control structure at the outlet if they know the field is flat, which is okay. The design comes in. If you want H2 hire payment or equip payment, then you have to have an engineering plan stamped and the paperwork to actually get paid for the structure and all that stuff. So um, typically this is a very detailed design procedure that I think I'm running out of time already, but I can explain to you. If you think you have a specific field, we can just design it for it at a later point and just go from there. If you come join us in March, you'll probably learn about it for about half a day. There, I don't talk about all this stuff. We give you actual examples to design it. This slideshow has those some of those examples for design, but there is a practice standard that NRCS will share with you. But I have given some website links that have all these resources there. If you have time now, you can look at it. Otherwise, don't worry about it. We'll teach you that whenever the time is appropriate. But a lot of people think that controlled drainage design is this controlled drainage design, and that's where they go wrong. You gotta think about this when you are thinking about a new tile system. Okay, so is this visible?
Yeah.
Can you make sense of it?
Yeah.
Okay, very simple. Okay, if I'm a conventional drainage contractor or a farmer that does not want to deal with having to maintain a specific grade and having grade breaks and whatnot because it's going up and down in topography. My best choice for a design is start putting laterals that go downhill. That way you're maintaining your 3 feet of depth as you're going down slope. No brainer, right? That the map on the left is designed that way. Every tile is going downhill, down to a outlet, down to a main that is north south. This is a field that is suitable for controlled drainage, but the tile system made it unsuitable for controlled drainage because now you got laterals that are going downhill. They are at the bottom of that stacked pancake. Okay?
Yeah. Yeah. Big time.
But the same field could have been designed with a much more expensive system, a more complicated system, following the natural contours of the line. You remember when we are going downhill, and if the laterals are intercepting the flow of the water, that's the best situation you have. So the design on the right has been modified, keeping controlled drainage in mind. Yeah, you don't have to go crazy on those turns. You could basically draw straight lines on your tile design, but the key difference here is you want to be parallel to the contour lines, not go across the contour lines if you are interested in controlled drainage on a field that has more than 1% slope. Does that make sense?
Yeah.
Flat field doesn't matter. Flat field, if you got less than a foot of a fall from west to east in the field on the left, that existing tile system will work. Because you remember, we want to raise the water table by about 1 to 2 feet. So if you have less than a foot of a fall in the entire field, who cares?
Right.
Okay, so
Over a decade, then, with those two systems, what would be the yield increase by the one that or projected yield increase
So-
for the one that has the controlled drainage structures in it?
that's a good question. Over a decade, would you see a difference in yield benefit from a system that's designed one way versus the other?
Yeah.
Short answer is no. If you designed it intensively enough that the entire field is within the zone of influence. I never used this term before. Okay, the bottom of the pancake where it was blue is called a zone of influence because when you raise the water table by 2 feet, it's only going so far before that basically falls below the tile lines. So that's the key. So if by doing the design where let's say half of the field actually benefited from the raised water level, your yield benefit is coming from only half of that acreage.
Yeah.
Versus the entire field being managed with controlled drainage, and then a lot of your benefit will come from the entire field. That's the difference. It's simply a math in number of acres rather than whether it
Yeah, that
would
makes sense. Yeah.
crop would be better with this layout versus that layout. Make sense?
Yeah. Yeah. Yeah.
Okay. I'm gonna run through these slides because I'm not gonna show you how to design it. You have to pay me
Right.
money to show you how to design it. I'm sorry,
Well
I'm
played.
forgetting that this is being
For a
recorded.
nominal fee, I'll show you how to design it.
That's fine.
Okay, just so you know, it's cost recovery on the drainage school. I spend more money on organizing it than we actually get back in registration fees. So, um, but anyway, if we were to offer it for profit, this would be 3 times more expensive.
There's a lot of sponsorship given to you on that too, is there still?
I For the last 70 years that it has run, the only sponsorships that are consistent is in-kind contributions from all the contractors, all the NRCS engineers that come in. They spend 5 days, and I don't pay anyone for their time. For last few years, I have gotten a sponsorship here and there because I like to organize some happy hours. University doesn't allow me to, so. But other than that, I don't need sponsorships on this. I allow our industry partners to come in and speak because you're dealing with a tile contractor, a pipe manufacturer. It's good for you guys to actually know who those people are, and they have more better insights, direct insights on it than what I can teach you. So it's kind of a, well, you got to be there to know how it works. So, but management zones, you remember, you understand how contour lines work. So you can see that like there are different management zones that you can create in your design. You see this in this design, they didn't even worry about the first contour line. The outlet would be at the 41.5, and they don't worry about that little zone there. They want to put a control structure starting from the first contour line into the field, because that gets them another foot of elevation control further up. So I'll show you some of the locations. See, if you put a control structure out there and there, then you got the blue and the green for the management zones. And here is a tile system that you could design around it, right? So it's pretty straightforward in a way, but you have to think about contour lines and where the zone might be before you put a layout. So that's the only nuance is in a drainage design procedure, you just don't take a contour map and start drawing lines. You got to think about where the control structure might go. And as I said, that gray zone is not ideal, so we don't want to manage that. So that's the actual design where you put a control structure at the right location, and that gets you much better coverage than the previous example. Okay. Um, Many ways to design these things. You know, if you're an artist, this is where you can get more creative. If you're a farmer, just be more realistic. Okay. Yeah, I mean, if this was for Vinayak's university research, yeah, I could bring in the funding to pay for 4 structures and get it all done. I can get my grad students to manage 4 structures. Do you want to have the hassle of managing 4 structures just for a piece of 20 acres? Probably not. Okay. 100 acres, 200 acres, yes,
Yeah.
definitely. Okay. Construction process, very simple. I already explained to you that you have to dig up existing main. You will have to retrofit that main with a non-perforated pipe. You have to make sure you stop your seepage. Um, All of this is, I think, coming from that NRCS standard. There is a construction standard that you can follow easily. I think if you know what you're doing on a tile installation job, you cannot go wrong with the installation. The most important thing you have to think about is this is a 6 foot, in some cases 8 foot tall vertical box that's sitting there. Your backfilling has to be absolutely perfect for it to stand in the position that it is. The moment it starts shifting, leaning in one direction or the other, it's also moving your outlet pipe with it. Okay, some of that is adjusted by having a rubber coupler, those Furnico couplers on either end. But the moment you start causing that shifting, you are calling for some trouble. So backfilling is the most important part. The structure has to sit on a firm base. You remember your tiling basics, your um, even your pull behind plow, look underneath it, it has to make a triangular notch for the pipe to sit in, because the plastic pipe is gaining its strength from the side support. Okay.
Yeah.
uh, but when you're installing your outlets, what do you do when you have wet bottom or soft bottom? You got to put some gravel underneath. You have to have firm bottom for the structure to sit. If you don't, then you have to make sure that you have the appropriate base for it. So there are all these considerations. You're not going to remember all this, but when you install it, if you have a problem, talk to your soil water guys or someone who has done it. Especially talk to them about the mistakes they have made, um, and then you'll know. So very simple. Just this installation process. You see the trench being dug and the structure being installed in a groove, and I think it has a firm bottom. This is good. This is good installation. Um, yeah, how to make sure that it's level and vertical. Um, the pipe has to maintain the flow line. You don't want to have a dip. So make sure you maintain it that way. Backfilling, as I said, is very important. Anti-seep collar is a nightmare, but kind of a important. Um, some guys go management. I think I explained it enough. Um, I'll just show you a graphic that shows um, where the seasonal management is. Oh, I messed it up. Okay, summer conservation mode. Previous one was winter time and higher. Summer is a little bit lower, but you're still storing the water. And then you have a conventional drainage mode whenever you need it. So around harvest time, if you do have too wet conditions, then you might want to put it in a free drainage mode. I haven't seen that happen in Ohio. Usually fall we don't have a lot of water in the soil, so I'm not worried about it as much. So if you look at the whole year, this is consistent with what I recommended earlier. Is your non-growing season, December, January, whatever that period is, you have the boards stacked up. So the top of this brown shading is the ground surface. About 12 inches below that is your aggressive management. But then in growing season, you want to start at the elevation that you're comfortable with. If you manage to store about 12 inches of water above existing tile drains in your first 2 years, I'll give you a medal just because I like this practice. Okay. After that, you can use it however you want. But when they say, oh, when you have no idea what to use as a cover crop and you don't trust the thing, then start with a cereal rye. You can't go wrong with it. Same thing.